All right, here we are at the last day of the semester, really, because after today, we're going to finish chapter 6, which is the end. That's all we're going to cover. We have Thanksgiving next week, so there's no class next Saturday. The Saturday after that is a review day, and the Saturday after that, final exams are due. So this is it as far as we got today. So to begin with, let's review exponential and logarithmic equations. The logarithmic equation is written this way. The conversion of it, if we were to convert from logarithmic to exponential, the base, this is the base, it would come over here and push up the solution. Since the base drops out, the log's gone, so we just have x. This is the relationship between exponentials and logarithmic equations. Also, since we can't calculate any log with a base other than an e or 10. So we can't calculate any logarithmic equation with a base other than e or 10. Remember, log base e so it's log base e of x, and so if you see an ln, that's actually a log base e. If you see a log with no number, that's log base 10. This is the only thing your calculator can do. So we use a change of base formula. So we have log base a of m. The change of base is we're going to make a fraction out of these two numbers. Whatever the operation is goes on top. Whatever the base is goes on the bottom. And we're taking them both to log base a. Because log base a is log base 10, and we can do that in a calculator. Or if we want to, we could do the log base e, ln's, the natural logs. It's the ratio that's important. Again, so whatever the operation is here goes on top, whatever the base goes on the bottom, and there you have it. There's where you could do the calculation. All right, let's look at some examples. Solving exponential equations. There's our example. 3 to the power 7x. We know it's exponential because the x is now the in the exponent, it's a variable. So that's what the whole chapter is about. Your first step is try to get both sides to the same base. So we have 3 power 7x. 27 is made up of 9 times 3, which is 3 times 3. So 27 is actually 3 to the third. Since we have the same bases, use the base exponent property. The base exponent property says this. If you have 2 exponential numbers and their bases are the same, the only way that can be is the exponents are equal. If that, then that. If you have the same bases, then the exponents have to be equal. So we have 3 to the power 7x equals 3 to the 3. Set the exponents equal to each other. And solve. So we know 7x equals 3. Then x equals 3 over 7. That's my solution. Let's look at another one. Because you do have to review your exponential rules, because we have this 12 from 2 chapters ago. So we have to review that. All right, so this is base 4. This is 16. 16 is actually 4 times 4. Since we have the same bases, we set the exponents equal to each other. 3x minus 5 equals 2. And solve for x. So you add 5 to both sides and divide by 3. So the answer is x equals 7/3. If it doesn't like that, then you have to convert it to, that's an improper fraction. 3 goes into 7 twice with 1 left over 3. So check to see how the system will accept your answer. All right, let's look at another one. Five to the power of 4x minus 7 equals 125. Since 125 ends in a 5, we know it's divisible by 5. 5 goes into 12 2 times with 2 left over. 5 was 25, 5. And that's made of 5. So what we have here, we have the same bases. 125 is 5 to the third. Since we have the same bases, we set the exponents equal to each other. And solve for x. X equals 10 over 4, which could be simplified to 5 over 2. Or 2 goes into 5 twice with 1 left over. So one of these two, the computer will take. There's another one. I've used a whole slew of these examples, so you won't get shocked when you see them for the homework or the exam. Three to the power x squared plus 4x equals 1 over 27. First off, 27, we know from earlier, is 3 times 3 times 3, or 3 to the third. No. Equals 1 over 3 to the third. From our rules of exponents, we know that a negative exponent simply means change the location. So if it's on top, it goes to the bottom. If it's on the bottom, it comes up on top. So in other words, basically what it says is when you move an exponentiated term from the bottom to the top, you change the sign. We have the same bases, so we set the exponents equal to each other. Oop, that's a square. Quadratic, so it has to equal 0, so we have to add 3 to both sides. X squared plus 4x plus 3 equals 0. It's quadratic, so we can try to factor it. Remember, if you can't factor it, then use the quadratic formula. That always works. X and X. The second sign's a plus, so they're the same signs. They are both plus. That's the first sign. What times what is 3? When you add them, you get 4. 3 and 1. And we set both of those equal to 0 and solve them. We get -3 and -1 as our solutions. Check your answers. Always check your answers. So the first one we're going to check is if x equals -3 from the original equation. 3 squared plus 4 times -3 equals 1 over 27. -3 squared is 9. 4 times a positive negative is negative. 4 times 3 is 12. 9 minus 12 is -3. -3 exponent is 1 over 3 to the third, which is what 127 is. So x equals 3 works. X and -3 works. Let's try x equals -1. So I put it in the original equation, -1 squared plus 4 times -1 equals 1/27. We know 1/27 is 3 to the power -3. We know that from just working it out. So -1 squared is 1. Positive negative is -4. 1 minus 4 is -3. Yeah, so both of those answers work. Okay. So that's examples we have there. Now, here's another property. The property of logarithmic equality. Here's what it says. For any number m greater than 0, any n greater than 0, a is greater than 0, and a cannot equal 1. So we have positive m, positive n, positive a, and it can't equal 0. Then what has to be true is this. If log base a of m equals log base a of n, then the only way that's true is if m equals n. That's the law of logarithmic equality. So you have the same logs on both sides. So if the logs are the same, then the equations have to be the same. Then the operations have to be the same. Now when would you use this? For example, log base 3 of x equals log base 3 of 5. Since both log base of 3, then the only way this is equal is if log x equals 5. What if, well, let's do some more. I'm gonna do some, I'll switch them in a minute. No, we'll use these now. So what if I had this equation? 4 to the power x plus 3 is equal to 3 to the power -x. They're not the same bases. So how do we fix that? If bases are not equal, take the log or natural log of both sides. Basically it says you can take the log of any number you want to. You can take a log base 4 or log base 3, and that'll eliminate that number. Because remember, log base a of a is equal to 1. ln of e is equal to 1. So we'll do this in two ways. So first one, I'm going to take the log of both sides. When you take the logs of both sides, what happens is these exponents now come in front, because that's one of the properties we had. So we have x plus 3, put that in parentheses because it's one equation, equals negative x log 3. Multiply to remove parentheses. So we have x log base 10 of 4 plus 3 log base 10 of 4 equals negative x log base 10 of 3. Combine like terms. Since we're solving for x, we have to get all the x's to one side, and anything that doesn't have an x goes to the other side. So this equation has to go to that side, and this equation has to go to that side. So subtract both sides by 3 log 4. And then I have to get rid of this one, so I add x log base 3 to both sides. And that's what I have so far. I have all the x's on one side, non-x's on the other side. Isolate the variable. And solve. So we have all the x's on one side and non-x's on the other side. So the way we isolate our variable on the left side is we can factor. They both have an x in common, so I take out the x, leaving me with log of 4 plus log of 3 equals negative 3 log of 4. Using the rules, log 4 plus log of 3 can be written as log of 4 times 3. We could condense it. Four times 3 is 12. So we could divide log of 12 to both sides. So x is equal to negative 3 log of 4 over log of 12. And there's your answer. Just plug that in the calculator and you're done. we had this one. 1000 e to the power 0.09 t equals to 5000. I'm just picking these out of the homework assignments at the end of the chapter. So again, our objective, isolate the variable. There's a variable, there's no here, so it's perfect. We have to get t by itself. So we have to get rid of anything added, subtracted first. There's nothing added, subtracted. Then multiply, divided. We divide both sides by 1000. Zero, 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 so equals 5. Since we're trying to get the variable by itself, we have to get it off the exponent. So since this is base e, we take the ln of both sides. The reason we took ln of both sides, because ln is already log base e. So log base e of e is simply the exponent. So those cancel, leaving us with the exponent. Divide both sides by 0.09. And there you have it. ln 5, that'll work in a calculator, divided by 0.09. And there's your answer. What if we had multiple sections with the same try to give them the same basis? 27 equals 3 to the power 5x times 9 to the power x squared. You cannot multiply these two together because they're not the same bases. So your first step, get to the lowest base possible. So 27 is 3 times 3 times 3, or 3 to the third. Three is as far as it can go. That 9 is 3 times 3, which is 3 squared. So 9 is 3 to the power 2 to the power x squared. Now that's a good sign. They're all base 3. Rules of exponents, whenever you have a power to a power, you multiply the exponents. So 2 times x squared is 2x squared. Now on the right hand side, if you have two bases that are the same being multiplied together, then you have to add the exponents. Again, these are all the properties we covered in exponentials. So it's 3 to the power 3, 3 to the 5x plus 2x squared. Since the bases are the same, we just have to worry about the exponents, since the bases are the same. The base exponent equivalency. Since it's quadratic, we have to set it equal to 0. So subtract 3 So we get 0 equals 2x squared plus 5x minus 3. Two x. Second sign's a minus, so they're opposite signs. The bigger number gets a plus. So multiply first and last. 2 times 3 is 6. What times what is 6? When we subtract them, we get 5. 6 times 1, 6 and 1. So 6 is positive, goes here. Factor whatever you can out. Erase whatever's been factored, and those are your factors. Set them equal to 0. And we get our solutions. -3 and x equals 1/2. Again, check your answers. These are 2 possible answers. Check your answers against the original. 27 equals 3 to the power 5x, 9x squared. Let's try the first one. 27 equals 3, 5 times -3, 9 times -3 squared. 5 times 3 is -15. -3 squared is 9. Remember, 9 is 3 squared. So it's 3 squared to the 9th. So it's 3 to the 18th. And 27 is 3 times 3 times 3. 18 minus 15 is 3. So yes, so -3 works. Does 1/2 work? 27 equals 3 times 1/2, 9 1/2 squared. 27 is 3 times 3 times 3. 3 to the power 5/2. 9 to the power, since I squared it, it's squared top and bottom is 1/4. Three to the 5/2. Remember, 9 is 3 squared. So squared 2 times 1/4, or 2 divided by 4 is 1/2. Add the exponents. 5/2 plus 1/2 is 6/2, which is 3. So it's 3 to the power 3 equals 3 to the power 3. So it works. They both work. So those are my solutions. Okay, we'll do a couple of them, then we'll do logarithms. E to the power x plus e to the power negative x equals -5. Okay, what this is, well, what you see here is this will be a quadratic equation. We have 3 terms. First off, what does a negative exponent look like? It looks like this. We can't have, whenever the rule is, whenever we have fractions and equal sign, the LCD, find the LCD, which is e to the power x. Multiply the LCD, so it's e to the power x times e to the power x. E to the power x times 1 over e to the power x equals e to the x times -5. Multiply to remove parentheses, so that's the only thing it cancels. I'm sorry, is reduce. And then that's step 3. Step 4 is multiply. And then step 5 is solve. E to the x is e to the 2x, because you add the exponents. X plus x is 2x. The ex's cancel. So it's -5 e to the x. It's a square term, so it's quadratic. Move this term. So we add 5 e to the x to both sides. Factor. Remember, whenever you factor, you're always factoring, you're solving for that middle term. So it's e to the x, e to the x. It's a plus, so they're both the same signs. They're both plus. What times what is 1? When you add them, you get 5. That doesn't work, so we can't use this method. Can't factor, so use the quadratic formula. X equals -b plus or minus square root b squared minus 4ac over 2a. Right? So what are, in our equation, a is 1, b is 5, c is 1. It's the coefficients. Since we're solving for e to the power x, this is what we're solving for, because you're always solving for that middle term. So that's what we're solving for, e to the power x. So e to the power x is equal to -b, so it's -5 plus or minus 5 squared, 4 times 1 times 1 over 2 times 1. -5, 25 minus 4 over 2. -5 plus or minus square root of 21 over 2. So it's e to the, so we take Since we're solving for x, we take the ln of both sides. Ln and e cancel. So these are my answers. So, all right. Let's move on to exponential equations. I mean, logarithmic equations. Solving logs. Log of x equals -4. Remember the conversion. The a pushes up the answer, and the log drops off. So since there's nothing here, it's log base 10. So the 10 pushes up the -4, and the log drops off. This is a negative exponent. There's your answer. X is equal to 1 over 10,000. Again, yet you have to remember your exponent rules. Log base 2 of x equals -3. Take the base, push up the answer, so it's 2 to the power -3. The log drops off. So x equals 2 to the power -3. Since it's negative, it goes to the bottom. 2 times 2 times 2 is 8. So x is equal to 1 over 8. Log of x minus log of x plus 3 equals -1. Since these two logs are the same base, but they're subtracted, that means that these are divided. We simplify it. That's the quotient rule. Has nothing there, so it's base 10. So push up the answer. So the base comes up, pushes up the answer, so the log drops off. So we have x over x plus 3 equals 10 to the power -1. Ten to the -1 is 1 over 10. Since we have equal sign of fractions, multiply both sides by the LCD, which is x plus 3. We have a fraction and equal sign, so LCD is 10. Multiply both sides by 10. So what we have now is 10x equals x plus 3. Because I multiply by 10, that cancels that out, times 10. Subtract x from both sides. 10 minus 1 is 9x equals 3. Divide by 9. 3 goes into 3 once, so there's your answer. Again, if you have two equations that have logs in there, look what sign is. Because if it's a minus, that means you can combine them by the quotient rule. If it's a plus, you can multiply them by the product rule. Log base 2 of 10 plus 3x equals 5. All right, so base is 2. It pushes up the answer. So we have 10 plus 3x equals 2 to the 5th. Remember, this is a base. It has to say the base. 2 to the 5th. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Solve for x. 3x equals 22. Divided by 3. 22 over 3, or 7 1/3. Let's do a couple more. Log base 3 of x plus 14 minus log base 3 of x plus 6 equals log base 3 of x. All right, so on the left-hand side, can we simplify? Yeah, it's subtraction, so we could rewrite these as log base 3 of x plus 14 over x plus 6 equals log base 3 of x. Since they're both log base 3, the only way they're equal is if the equation parts are equal. We have fraction and equal sign. So multiply both sides by the LCD, which is x plus 6. X plus 14. X squared plus 6x. It's quadratic, so set equal to 0. Subtract x from both sides. Subtract 14 from both sides. Zero equals x squared. 6 minus 1 is 5x minus 14. X and x. Second sign's a minus, so opposite signs. The bigger number gets a plus. What times what is 7? What times what is 14? When you subtract them, you get 5. 7 and 2, 7 minus 2. So 7 gets a positive. Set those equal to 0, you get negative 7 and 2. Check your answer. Remember, our original equation was log base 3 x plus 14 log of 3 x plus 6 equals log of 3x. Our two possible answers are negative 7 and 2. I'll look at both of those. Negative 7 plus 14 log base 3 of -7 plus 6 equals log of base 3 of -7. You cannot take a log of -7 and know that, but -7 plus 6 is -1. You can't have that, so -7 cannot work. Let's try 2. 2 plus 14. 2 plus 6. 2. So log base 3 of 16. Log base 3 of 8. These are log base 3 of 2. These are subtracted, so I could divide them. Log base 3 of 16 divided by 8 equals log base 3 of 2. 16 divided by 8 is 2. And they work. So that's our only solution. Whenever you get an answer, always check your answers. Make sure it's right. What if we had logs on both sides? I mean, equations of logs on both sides. Treat them both separately. So that's a plus. So that means I can combine the left side by multiplying these two. And I could do the same thing, since it's a plus, I could do the same thing on the other side. Since they both have log base 3, then I set the equation parts to be equal. Quadratic, so move everything to one side. Subtract 2x, subtract 6. X squared, -2x plus x is -x minus 6 equals 0. Factor them. Second sign is a minus, so they're opposite signs. The bigger one is negative. What times what is 6 when you subtract them, you get 1? 3 times 2. Set them equal to 0. You get -2 and 3. Since you cannot have a negative number of logs, so the only one that could work is 3. And if you see that, it'll work. Log base 3 of 3. Log base 3 of 3 plus 1. Log base 3 of 2. Log base 3 of 3 plus 3. Since this is 3 plus 1 is 4. Since they're added, I can multiply them. Log base 3 of 3 times 4 is 12. 3 plus 3 is 6. 6 times 2 is 12. Remember, log base 3 plus log base 3 of 4. Since it's the same logs, I can take the numbers, since they're added, I can multiply them, which is why I get log base 3 of 12. All right, one more, then we'll finish up the chapter. We'll do chapter 6. Only 2 sections in that one. We haven't seen one of these before. A log base 3 times a log base 4 of x. Do you think, do we multiply those? Do we exponent? No. Treat them both separately. Here's a log. It equals something. So take the base. 3 to the power 0 is equal to log base 4 of x. No, 0, no. So the 3 goes over here to the 0, logged up, and then we have that. Anything to the power 0 is 1. So the base comes over here, pushes up the answer. So it's 4 to the power 1 equals x. So x is equal to 4. That was a tricky question. All right. That's the end of chapter 5.